Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. Today we are going to discuss about the topic formation of partial differential equation by elimination of arbitrary functions. This lecture includes definition of partial differential equation, what is dependent and independent variables, eliminating arbitrary functions. Partial differential equations. That is an equation which involves one or two partial derivatives. The equation, if the symbol it is there, dou, we will pronounce it as dou. If the equation it has this symbol dou, it gives an indication that the particular equation representing partial differential equation. The PDE, the expansion is partial differential equation. Now, dou z by dou x, dou z by dou y. Three variables are there. Here what is written in this? That is x, y and z. Three variables. Among these three variables, this x and y, they are playing the role of independent, or the variable z which plays the role dependent. So compulsory our partial differential equation, at least it should have one dependent variable. The word at least, the minimum compulsory it should have. More it can be anything more. At least two independent variables it should be there in the partial differential equation. The notations: dou z by dou x, which is denoted by small p, dou z by dou y, which is denoted by small q, and dou square z by dou x square. That is, this dou z by dou x, only one time we did the differentiation partially, whereas here two times it has been done the differentiation partially. The symbol which is denoted by this two times the differentiation is dou square z by dou x square. It is denoted by small r. Next, dou square z by dou x dou y. It is represented by s. Dou square z by dou y square. It is represented by small t. So p and q, they are playing the role of first order. That means only dou. Only one time we are doing the differentiation. The degree is also 1. So first order linear equation. Whereas this is two times we are doing the differentiation. So second order linear equation. Second order, but the degree is only 1. The degree is 1. So completely we are going to discuss this. Notations are given linear equation because the derivatives, the degree is 1. Yeah, small actually examples we can see how to do the partial differentiation. Now z equal to x plus y. The left side we are doing the differentiation partially with respect to x. So dou z by dou x, partially with respect to x. So x, the differentiation is 1. Whereas the y, it is an independent variable, but here we are considering and we are concentrating only on x. So other variable we have to neglect it. So we neglect it. Then dou z by dou y. So if it is dou z by dou y, That is partially we are going to do the differentiation with respect to y we are going to do. So y we are going to do, so this x is another independent variable, we will neglect it. Y differentiation is partially, it is 1. The next example is z square equal to x cube plus y square. So the left side is z square. So we will do the differentiation. The formula is, if it is x power n into x power n minus 1. So our n is here playing the role 2. So 2z power 2 minus 1. Again z we have to do the differentiation, and the variable z which is playing the role dependent variable. That is the reason that z, the differentiation is dou z by dou x. So here it is written. Next, x cube, very easily 3x power 3 minus 1, because n is 3, we substituted here. Then x differentiation is 1, it is written here. Whereas y we won't consider at all. We won't do the differentiation this y variable, because we are favoring, we decided to give importance to this variable only x. We neglected y, so the neglected which resulted as 0. Next, this is our question. Now, with respect to x, partially we completed. Now we will move to partially with respect to y. Now z square it is there. Partially with respect to y we are going to do. Then z square it's nothing but 2z. Again z differentiation is dou z by dou y equal to x. The differentiation partially is 0, because we are considering the variable y. If we are considering the variable y, another variable are treated mathematically, it is constant. They are treated as constant. Otherwise, very explanation, easy way to give, we are neglecting other variables. So here other variable is x, we neglected, it has become 0. Whereas y square, we are considering, we are going to do the differentiation partially with respect to y. So y square, the differentiation is 2y power 2 minus 1 equal to 2y. It is written y differentiation is 1. So the third example also we can see it. It is different from these two examples. Now z square equal to x cube y square. We will do first partially with respect to x. Here the left side, it is very clear. 2z, z differentiation is dou z by dou x. Then x cube, the differentiation is 3x square, which is already explained in the previous example. But why to write y square here? Because the previous two examples, the explanation which is given, if we are doing partially the differentiation with respect to x, neglected y. If we are partially differentiation with respect to y, we neglected x. But the third example, why it is not done? Y square is written. What is the reason? What is the difference between the before examples and this example? The reason is the two variables are there, x and y. They are combined with our mathematical operation addition. The four operations are playing the role in mathematics: plus, minus, multiplication and division. They are the symbol of these operations. But plus and minus comes we will neglect it. The variables here, connectivity is plus. Whereas here in this example, the two variables connectivity is multiplication. These three examples, if the students are very clear about it, there is no careless mistake. It won't occur at all. So x cube y square, these two variables combined with the multiplication, that is the reason if we are concentrating the variable x also, y square is written if they are combined with the operation multiplication. The next one we are going to do partially with respect to y. 2z dou z by dou y. Next, x cube, it is written. Even though we are favoring y, other variable also written because these two variables combined with the operation multiplication. So y square, the differentiation is, we applied the formula y square. So 2y, the power is 2 minus 1 equal to 2y. So x cube into 2y, we got it 2x cube y. So from this slide, we got a clear picture about it. The variables are combined with which operation? That is the most important basic thing. We have to know it along with the definition of partial differentiation. So now we are going to form a partial differential equation by eliminating the arbitrary function. This is the z equal to f of x square plus y square, which is given. Now solution. The arbitrary function, that is, here f is there. Completely, now the notations we discussed it. P, Q, R, S, T. Before the first slide which was explained. So now using those notations, any notations, this final, the result, what is the required, the solution finally, what we are going to get. Otherwise, what is our target towards this problem? How to solve? This f should be removed. That is, f of, the function is f of the some term it is there, the term which has the variables x and y. The final result x and y can play a role, but f should not play a role. It should be eliminated. That we are going to do now. So the given equation is z equal to f of x square plus y square. This is named as 1. So we are doing the differentiation, the equation 1 partially with respect to x. Yeah. So we know it, z with respect to partially. That is the reason partially. The simple compulsory dou should be there. Dou z by with respect to x. That is the reason here dou x. F of some term. So f differentiation is f dash of some term. So up to here it is very clear. Then f dash of some term, the some term which has the variables x and y. Again that we should do it. So x square, the differentiation is the formula 2x 2 minus 1. It's nothing but 2x. That's what it is written. But y square, we neglected it. Because we are concentrating only x. Y square is neglected. So we got it. F of x square plus y square, the differentiation is partially f dash of x square plus y square into 2x. And dou z by dou x, the notation is small p. So the left side we can write it small p also. So we can write it. So we wrote it the left side as small p, and as it is written, given equation, we named it as equation 1. This we are naming as equation 2. So now we completed a small streamline, that is partially with respect to x we did. The same, what are the treatment we have given to the given equation, we are going to give with respect to y. So this is our question, given question. We named it already equation 1. And so dou z by dou y. Now we decided to favor with respect to y. So f of some term, the variables are x and y. So f of, it's nothing but f dash of sum, the terms. So again the sum term, f dash of. So x square is neglected as we are favoring towards y, that is 2y. So dou z by dou y, which is represented as q. Now, so dou z by dou y, in the place it is written q. So f dash of x square plus y square into 2y, this equation is named as equation 3. So far what we have done it. What is our target? Our target is the given question. This is that the final answer f to be removed. That is the topic, elimination of arbitrary functions. Now divide equation 2 and 3. Why specifically we have to take a division? Why not multiplication, addition, subtraction? Anything we can take it, which is easy, which is consume our time. But final result, the function should not be there. So here we have taken division, divided by this equation 2. This is equation 3. Both we are dividing, the 2 cancelled, and the function also, it is completely eliminated. So p by q equal to x by y, and we did the cross multiplication, py equal to qx. So py we are bringing to this side, which is equal to 0. That's what we got it here. So if you are noticing the final, this is the required solution for our given equation, and completely the function f is not at all seen here. We removed it. So the next problem we will see it. Eliminate the arbitrary functions pi 1 and pi 2. The previous problem what we discussed, f of x square plus y square. There f, only one function is there. And what about this problem? This problem, pi 1 and pi 2, two functions are playing their role. So if it is one function, we noticed that the previous problem we did p and q, that is dou z by dou x we concentrated, dou z by dou y we concentrated. Only one function, we stopped up to first order itself. But whereas coming to here, pi 1 and pi 2, two functions are there. It's not only stopping up to first order, we should move forward towards second order also. This point is very, very important thing. We have to keep it in our mind. So this is our z equal to pi 1 of x plus iy plus pi 2 of x minus iy. So the given equation is, so the given equation, we named it as 1. So the equation 1, partially with respect to x we are doing. So now dou z by dou x. Pi 1 of x plus iy. That means pi 1 of, it has some term. The term, it's complex. Real is the real part is there, complex part is there. it has the variables x and y. So pi 1 of, so it's the differentiation, pi 1 dash of some term. Again the sum term we have to do the differentiation. The x differentiation is 1. Why we are not touching this part? Because we are favoring, we are concentrating only partially with respect to x. That is the reason we didn't touch this y at all. The next coming to here, pi 2 of x minus iy. So pi 2 of, then pi 2, the differentiation is pi 2 dash of x minus iy. Again this x minus iy should be done the differentiation. The x differentiation is 1. So we simplified it here. So we know it, pi 1 dash of x plus iy into 1. The same result will come as it is, because 1 is the multiplicative identity which plays a role in mathematics. If you multiply with anything by 1, it won't affect the result. That's what the 1 is called, multiplicative identity. Here also 1 is there, multiplicative identity. So we got it, pi 1 dash of x plus iy, pi 2 dash of x minus iy. This is named as equation 2. Now the same equation we are going to do second time also with respect to x. The reason is, our given question, two functions are playing a role. They are pi 1 and pi 2. So it is the equation 2. This we are going to the differentiation. So now dou z by dou x. Once again we are going to do with respect to x. So dou z by dou x is written as dou squared z by dou x square. Now pi 1 dash, the differentiation is pi 1 double dash of some term. The sum term which has the variable x and y, in which we are going to do favor, we are going to concentrate only x. So the x differentiation partially is 1. We neglected this part. The same way this is also pi 2 dash. Again the differentiation is pi 2 double dash of the same, the sum term which has x and y variable we wrote as it is, and inside these x and y variables, x we are doing the differentiation partially. The result we got it 1. We neglected this part. Now simplification we did. So this part into 1 as it is will come, because 1 is a multiplicative identity and this is also written as it is. This we named it as equation 3. So the given equation, first time we did the differentiation, we got the result that we named it as equation 2. Once again we did the differentiation, that is a second time also we moved towards partially with respect to x. That equation we named it as equation 3. So completely the treatment to the given equation with respect to x, the job is over. Now we will move how to deal the given equation with respect to y. So this is our given equation. So now dou z by dou y. So it is written dou z by dou y. So pi 1 of the differentiation is pi 1 dash. So of x plus iy. So here we are partially with respect to y we are doing. So iy is there, y differentiation is 1. The coefficient will be written as it is. Here pi 2 of, then pi 2 dash of. Then the inside one also we have to do the differentiation. X is neglected, but minus iy. Y differentiation is 1. the coefficient will come as it is, then minus I. Next, we are doing the simplification. Just we brought this I front, then I into pi 1 dash of x plus iy. This minus I, we brought it just front. So minus I into pi 2 dash of x minus iy. This equation which is named as 4. So now the equation 4 is ready. Again we are going to do the differentiation. So dou square z by dou y square. So I is written as it is. So pi 1 dash, which is written pi 1 double dash of x plus iy. So minus I, here it is written pi 2 dash, which is written pi 2 double dash of the term which has x and y variables into the term which should be differentiated again. So minus iy. Y differentiation is 1 into minus I. It's nothing but minus I. That's what it is written here. So here dou square z by dou y square. Here if you are noticing I into I, it is there. I into I, it's nothing but I square. I square, the value is minus 1. Here it is kept minus. If you are noticing this step and this step, I is there, but here minus sign is there because I square is replaced by minus 1. Here minus into minus plus I into I square. Again I square value is minus 1. That's what here the minus sign is there. So this is the equation 3, we got it. This is our equation 5. We are adding these two equations, that is this equation plus this equation. When we are adding this cancelled and this two terms are cancelled. So the left side is this plus this equation, which is equal to 0. Now this notation is R, this notation is T. If you are noticing the required solution, what we got it completely pi 1 and pi 2. Two functions, they are completely eliminated. We will come to a conclusion about this topic. First we discussed what is partial differential equation. That is, it should have at least one dependent variable z, at least two independent variables it should have. Then problems we concentrated, how to eliminate arbitrary function. Here only one function is there. So P and Q, they are concentrated, that is dou z by dou x, dou z by dou y. We stopped up to first order because only one function is there, and we got this is the solution. One more problem, two functions keeping we discussed. As it has two functions. This is the given equation. So we moved it to 2 times we did the differentiation. Final result we got it R plus T. Completely pi 1 and pi 2, the functions are eliminated. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.